Welcome to The Explainer. Today, we're diving into the world of chemistry to become detectives. Our mission is to unmask 6 common gases that you can't even see.
So how do you even begin to identify a gas you can't see? I want you to picture this. You've got 6 test tubes right in front of you. They're all filled with a colorless gas. They look identical. So how on earth do you tell them apart? Well, it turns out there are some pretty clever and sometimes even dramatic little tests we can do.
And here they are, our 6 invisible suspects. We've got ammonia, chlorine, carbon dioxide, hydrogen, oxygen, and sulfur dioxide. Now, each one of these has its own unique chemical personality, and we're about to find out exactly what those are. All right, first up, trial by fire. We're going to jump right in with our first couple of tests, and these are probably the ones you remember from chemistry class. They both involve a simple wooden splint and, you guessed it, a little bit of fire. So for our first test, we're on the hunt for hydrogen. And the method is pretty simple, really. You just take a test tube with your mystery gas, light up a wooden splint, and then you stick that burning splint right into the mouth of the test tube.
And if you do have hydrogen, you're gonna know it. The heat from that flame causes it to react explosively with the oxygen that's just in the air around it, and it makes this really distinctive squeaky pop sound. It's basically a tiny little explosion, and it's the unmistakable signature of hydrogen.
Okay, so what about oxygen? The test is super similar, but there's one really important difference. You start by lighting a splint, but then you gently blow it out. You want it to be just glowing red at the end, no actual flame. This glowing splint, that's our key to finding oxygen.
Because if that gas is oxygen, something pretty cool happens. The glowing splint will just relight, it bursts right back into a flame. It's this perfect, dramatic demonstration of how oxygen fuels fire. It's literally the lifeblood of combustion.
So, you see the difference, right? It all comes down to the state of that splint. A lit splint giving you that squeaky pop, that's hydrogen. A glowing splint that relights, that's your oxygen. 2 totally different reactions, all from one simple little piece of wood. Okay, let's move on to our next section, the litmus test. We're putting the splints away for now, and we're bringing out another chemistry classic, litmus paper. This little piece of paper is going to reveal the true colors, so to speak, of our next couple of gases.
First up is ammonia. Now, ammonia is what we call an alkaline gas. You've probably smelled it before. It's got that really sharp scent you find in some household cleaners. The test is to take some damp red litmus paper and stick it in the gas. That little bit of water is key because it lets the ammonia dissolve and show its true alkaline nature by turning that red paper blue. Chlorine is really interesting because it gives us a 2-step reaction. So you start with damp blue litmus paper this time. At first, it'll turn red. Why? Because chlorine dissolves in that little bit of water to make an acid. But wait, there's more. Chlorine is also a powerful bleach, think swimming pools, and that bleaching power takes over and turns the now red paper completely white. So it goes blue to red to white. Pretty unique.
All right, we're now 4 down, 2 to go. For our final 2 gases, splints and paper aren't going to cut it. We need to step up our game a little. We're going to see how these gases react when they're bubbled through some specific liquids. And for carbon dioxide, we use an absolutely classic test, the Limewater test. Now, Limewater is just a clear solution of something called calcium hydroxide. It doesn't look like much, but it is the perfect tool for finding CO2.
And what you do is super simple. You literally just bubble the gas you're testing through the Limewater. That's it. The whole trick is to just watch that solution really, really closely and see what happens. And here's what you're looking for. If you have carbon dioxide, it reacts in the Limewater and forms something called calcium carbonate, which is basically a solid. And all those tiny solid particles are what makes the clear solution turn all milky and cloudy. You might have even done this one in school by blowing through a straw into Limewater to prove you breathe out CO2.
Okay, 1 gas left, sulfur dioxide. To find this one, we have to use a cool chemical property. See, sulfur dioxide is a reducing agent. What does that mean? Well, it means it's really good at reacting with and basically neutralizing a strong oxidizing agent. It's like a chemical tug of war, and sulfur dioxide is great at winning. So the oxidizing agent we used for this test is this really vibrant, deep purple liquid called acidified potassium manganate 7. And when you bubble sulfur dioxide through it, the magic happens. The sulfur dioxide does its job as a reducing agent, and that beautiful purple color just disappears. It goes completely colorless. And there you have it. Just like that, we've identified all 6 of our invisible suspects. We used fire, we used paper, we used special solutions, and we made the invisible visible. So let's put it all together in our final chemist toolkit. Think of this table as your ultimate cheat sheet. It lays everything out nice and clear. For every single one of our 6 gases, there's a specific test and a totally unique result. You've got the squeaky pop for hydrogen, the Limewater turning milky for CO2, the disappearing purple for sulfur dioxide. Each one has its own telltale sign.